Introduction, Materials, and Procedure. Students will observe a mass spring oscillating system and use time measurements to solve for the period and then find the spring constant. The spring constant will be found using algebra and also graphing. You will need a stand to hold the spring, a spring, masses to hang from the spring, and a stopwatch to time the period. Before the students arrive, you should set up stations with a mass spring oscillating system and a stopwatch. The lab suggests 50-gram masses. This will vary depending on the spring constant of your particular springs. Make sure that the mass you place on the spring will extend it no more than 50% of its original length. We don't want to stretch it out and damage it. Make sure that when the mass is giving a small displacement, it oscillates smoothly. Students will complete this procedure. Attach a light mass to the spring. Displace it a small amount, 1 to 2 centimeters, and record the amount of time it takes for the mass to complete 10 oscillations. Repeat the trial each time with a slightly heavier mass. Record all data. Warnings. Make sure there is space for the spring to bob up and down without hitting your lab table. Overextending your springs will cause them to stretch, and they will no longer obey Hooke's law. And this is kind of presumptuous. They're not obeying anything, but they won't be defined by Hooke's law. Some good springs, see, they're not terribly stretched out. And these are springs that were overextended at some point, and you don't want to use them. See the distance between the coils here, and then there's hardly any? That's not good. Rambunctious students may overextend the spring with the mass on it. This could cause the lighter masses to fly off the spring into the air. So wear safety glasses and caution students to work carefully. A sample of the data table is shown below. After completing at least 3 trials, the time data can be averaged for each mass. All right, here's a mass 50 grams. So you have 3 trials. You would average that, divide it by the number of vibrations, which should be 10, and this will give you the period. Now be careful, you may record your data in grams, but when we go ahead and calculate K, you have to switch that to kilograms, to SI units. Please click here to have a video of the lab procedure. Some tips: be sure students are counting 10 full back and forth motions. Each one would be a period. Overextending springs is probably the biggest concern with the lab. Monitor groups to make sure they are using the equipment properly.